Welcome. I'm Mike Katungu, Professor Mike Katungu, your tutor, and in this video we are going to discuss and we are going to learn about probability and sets. Now, in our last video we said that probability is a likelihood that something will happen, that something will occur actually. So now we are going to discuss this probability alongside sets. Okay, so we said that probability of an event is the likelihood that something will occur. Where there is probability, or whenever people talk about probability, they talk about chance or likelihoods. Okay, so this is what we discussed in our previous videos, and we solved questions on probability. But in this video we are going to solve questions that are relating with sets. Now, we all know that whenever there is a probability, there are likelihoods. There are a number of likelihoods. Whenever there is an event, outcomes are expected to come out. So those outcomes are what we use to calculate our probabilities of that event. Okay, now suppose we roll a die. Okay, so suppose we roll a die. Okay, so a die, let's call this, it has numbers 1, 2, 3, 4, 5 and 6. So we are going to call this the sample space, or rather the probability space. So this is where our number of outcomes or chances of particular events, okay, it gives us the number of outcomes. Okay, in short, this is called the set of outcomes. Okay, so this is called the set of outcomes. That is a sample space, also known as the set of our outcomes, and that outcomes is based on the events that we want to find. Okay, suppose we are told to find, okay, the probability that the event of picking an even number would say, okay, the probability, how many even numbers are in our sample space, or that are within the range of the expected outcomes. We have 2, 1, 2, 3. So we have 2, 4 and 6. All these are even numbers. So we would say it's a 3 chances of getting an even number over the 6 possible outcomes. That would be a half. Okay, but in this video it is mostly concerned with sets. We see that this we call sample space also gives us is the set of outcomes. Okay, so if we have the set of outcomes, and the set, we say that a set is a collection of things, okay, a collection of well-defined objects. Okay, so we say, okay, in here we have the set, this is our sample space. In here we have the set of even numbers, which is 2, 4 and 6. Okay, odd numbers, okay, which is 1, 3 and 5. So these odd numbers, we can say these sets, we can actually call them subsets of the possibility space. Okay, so it is only right according to set theory that since these produces even numbers, and also these contains odd numbers. So it is only right for us to say that these are subsets of this sample space. Okay, so I'm sure you're getting the hang of it. So at first we said probability is the likelihood, and then we say that whenever there is an event or whenever an event happens, there are expected number of outcomes, that we expect a number of outcomes, and that outcomes forms the sample space, or outcomes, a number of outcomes, they form a set. A collection of those outcomes is a set. Okay, so we're going to discuss in line with that. Okay, so I'm going to assume that you know a bit of set theory and some stuffs for sets. Okay, so if we at all way to define this in a Venn diagram, okay, so this is a diagram that helps us to see our sets clearer. Okay, so let's call the sample space, let it be the universal set. The universal set, okay, a set that contains all the possible outcomes. Let it be the universal set. Okay, so we're going to do this, and then these even and odd numbers. So it is going to be like this, then even and odd. Okay, so we are going to write this. Okay, so this said probably it's a mistake. Okay, if I do this, okay, so like this. Okay, probably this is a mistake. Anyway, this is a mistake. What I'm trying to say is that if at all we illustrate this information on a Venn diagram, I'm trying to say that it's going to look more like this. Okay, all right, we have our even numbers. We have 2, 4, 6, and then we have 1, 3, 5. Okay, so this defines our sample space. This defines our probability space. So this, if we at all we translate it, it may be like this: 2, 4, 6, and 1, 3, 5. This is the illustration of this. Okay, so let's solve a question. Okay, so yeah, I was trying to explain to you, but I'm going to do that through solving the questions so that you understand. Okay, so we have questions on probability mixed with the sets. Okay, and then we have this question. Question 1, a universal set has 24 elements, and A and B are subsets of the universal set such that the number of elements in A equal to 14 and the number of elements in B, they equal to 9. So number of elements A intersection B is equal to 6 if the probability of A is the probability of selecting an element belonging to set A. Calculate PA. Okay, so let us do this. We are going to solve this question. So okay, if we were to do this, so they said that the universal set, okay, has how many elements? It has, the universal set, it has 24 elements. So we are going to imagine that this is a set of our outcomes, the set of our outcomes of different events. Let us imagine that. And then we are told that they are A, B, these are the subsets, they are part of the universal set. So they are said number of elements in O of A is equal to 14. Number of elements in all of B is equal to 9. Okay, so we have this information. Okay, so what we know is that to solve this question, we have to define this, we have to convert this into, okay, we illustrate this information in a Venn diagram. Okay, in a Venn diagram, we know that we have the subsets A and B, and they probably have an intersection. Okay, so now let us represent the elements in here. Let's say it has 24, so we're going to represent that with our letters. Okay, so here suppose we have 6. Say that the number of elements A intersection B is 6 here, 6, and the number of elements, so here number of elements A intersection B is equal to 6. Okay, so if this is 6, the whole of 14, so here it's 14 minus 6, so that is the number of elements in this. Here it's 9 minus 6. Okay, 9 minus 6. All right, so in here this is what defines. So here is 9 minus 6, and here 14 minus 6. Okay, that is the number of elements. And then let us not forget, this is A and this is B. They are all subsets of the universal set E. And then to speak of that, this E, okay, the universal set has a total elements of 24 elements. Okay, so if we subtract this, this will be equal to 14 minus 6, that will be equal to 8, and 9 minus 6, that will be equal to 3. Okay, so that adds up 2 plus 6. Okay, this is probably 9, of course. 9. 2 plus 6 is equal to, 14 minus 6 is equal to 9, and what am I doing? So this is 8, as I said before, and this is 3. Okay, so what this means is that the number of elements in just this part of this area, the number of elements is equal to 8, and this area, what it means is that the number is equal to 3, so that when we add this and this, the whole of this, it gives us what? It gives us 9, and when we add this, the whole of this, it gives us 14. Okay, so that makes sense. All right, so what we are going to do now, we are going to say if PA is the probability of selecting an element belonging to set A, calculate the probability of getting A. Okay, the probability of getting A would say, the probability of A would say out of 24 outcomes, okay, 24 outcomes, we have 14 chances that the element that we will get is from A. We have totally 14 chances that it is A. So if we simplify this, 2 in here, we say 2 in here, that is a 7, 2 in here, that is a 12. So this is the simplest fraction. And then we come to the next, the probability that it's within the intersection of A and B. The probability that it's within the intersection of A and B, will simply say the probability that is within this intersection, it will be out of 24 outcomes, we have only 6 chances that what we pick is within the intersection of A and B. Okay, so if we say 6, 1, 6, 4, so this is a fraction for the second one. Now see here the probability that what we're going to pick is an element that is in the universal set but is outside of B. PB complement. So we are going to say to find the complement, we are going to say E is equal to 24. 24 minus 14 minus 9. So 24 minus 14, this is 0, this is 10. 10 minus 1, this is 10 minus 9, this is 1. So an element outside here is probably 1. Okay, so I hope you are getting what I'm trying to explain here. I'm trying my very best to explain to you. So what it means is that this plus this plus this, it adds up to, okay, this plus this, it adds up to 23. But now we have 24 elements, so which means the one outside the universal set, which is neither in this set, see, it's simply just an element. We'll say it's 1. Okay, so it's one element which is there. Okay, so this will be the number of elements, okay, out of 24 possible outcomes. Okay, out of 24 possible outcomes, we only have 3 plus 1 chances of getting PB complement. So this is 24 over 24, 1, 8. So this will be 1 over 8. 1 over 6. No, it's a mistake. 1 over 6, I mean. Okay, 1 over 6. All right. So that is, and then PB D. Okay, D, it says P A union B complement. P A union B complement. The probability that what we are going to get, it's in the universal set, but again it's not in the union of A and B. So out of 24 outcomes, we have 1 chance that what we're going to pick is just outside the union of A and B. We have 1 over 24. That is our chance. All right. So, right. Hope I solved that question. Now we go to question 2. Okay. We go to question 2. One element is selected at random from the universal set of 15 elements. R and Q are subsets of the universal set such that the number of elements in R is equal to 6, number of elements in Q is equal to 8, and number of elements R intersection Q is equal to 12. Okay, so we only need to illustrate this information in a Venn diagram. All right, so let's do this. Okay, I'm going to say this is our universal set and this is our Venn diagram. Okay, so we have the subsets in our Venn diagram. Okay, we have the subsets R and Q. These are our subsets. And then we have the elements, the total number of elements here. We are told it's 15. R and Q are subsets of the universal set such that the number of elements, okay, we're going to say number of elements R, okay, R intersection Q is equal to 12. Okay, is equal to 12. And then number of elements in R is equal to 6. Okay, so this simply means it will be number of elements in this okay, number of elements in R intersection Q is equal to 12 number of elements in E. So what this means is that 12 minus 6, it's 6 here. Q is equal to 6. Okay, so here we have 6 and here we have, okay, so cancel this one. Okay, so we have something like this. We have something like this. Here we are told that the number of elements R intersection Q, it's 12. So this is R, this is Q. Okay, so if this is 12, what about this? So we're going to subtract the 12 from the ones that are in the whole set. Okay, so from the ones that are in the whole set, that would be, you know what, let's read the question 2 again. One element is selected at random from a universal set of 15 elements. R and Q are subsets of the universal set, and number of elements in R is equal to 6, number of elements in Q is equal to 8. So I guess this time around we'll be successful. See, to be good doesn't just come over time. We have to practice. So this is it, and then this is our universal set, our subsets R and Q. But then we are told that the number of elements in this intersection, number is equal to 2, and in this area we are told that the whole portion of this is equal to the whole thing, the portion of all this. The number of elements in whole of R is 6. So that means 6 subtracting the 2, including the 2 here, we have 4. Okay, number of elements being 4. And then going to Q, we are told that the whole of Q, of set Q, the elements are 8, but we already have 2 that take Q, or 2 that are in Q. So we subtract this, it would be number of elements is equal to 6. Okay, so we have solved this. Then calculate the probability of Q. The probability that the one that will select, the random selection, will be on Q, will select the ones that are in Q. So we'll consider out of 15 possible outcomes. Okay, out of 15 outcomes, we have 8. We have 8 chances that the ones we select are from Q. Then we go B. So this is A. B, the probability that it would be R union Q. So R union Q, that would be 6 plus 8. Okay, 6 plus 8, that would be 15. 6 plus 8, that would be 15, 14. 6 plus 8, it's 14. So it would be 14 over 15 our possible outcomes. So out of 15 possible outcomes, we have 14 chances, or there are 14 possible outcomes of selecting an element in the region of R and Q. This whole region of R and Q, there are 14 over 15 possible outcomes. All right, and then C, the probability of getting an element outside R but is within the possible outcomes. So this would be 15 Then 15 possible outcomes. The ones that are outside R, we will consider 6C. Okay, so 6C, we also consider 1 outside here, so it would be 7 over 15 possible outcomes. Okay, so this is 6. 8 plus 6 is 14, so but we have 15, so 15 minus 14, that would be 1 outside here, so 1 plus the outside 1, that would be 7. So it is 7 over 15. That is our probability. And then D, we are told to find the probability that the elements will end up with it's within R intersection Q. So that would be 2 over 15. This is our probability. Okay, thank you for watching this video, and if you like, please subscribe. Although I was really a bit cracky and yeah, but otherwise I hope you understand this video, because I've really tried to break down information into little bits so that you understand. Well, the best thing is just to take set theory. That's the best thing. Otherwise, I hope you understand. If you like this video, please subscribe. But until now, wait until next time. Bye bye for now.